So, Nick gave a presentation a while ago about an introduction to FPGAs, and subsequently he and I chatted and dreamed up a community project, and the name is really TBD. These two names are just you know, what occurred to us, and that's it. So next slide. We're focused on FPGAs, which stands for Field Programmable Gate Array, and I was surprised to find that a FPGA only has 4 things in it that are worth mentioning. Buffers that can take very weak signals and make them strong and drive you know, source and sink current, and also condition inputs and various things like that, kind of super duper GPIO pins. And then it's got this animal called a lookup table, which can be thought of as commonly 4 or 5 input, single output Boolean expression thing that is literally the 4 inputs, call them A, B, C, D, resulting in a single output, such as A, N, B, N, C, and D, or extremely complex Boolean expression that involves all 4 of those variables. And then it's got flip-flops, which are can be thought of as simple as you can get memory. So you can kind of keep track of the current and the past, present, and future. And face-lock loops that allow you to generate more or less arbitrary frequency clocks, which in this context are just square waves. And that's all that's in an FPGA. Ordinarily, there are other things that can be thought of as combination of flip-flops, namely RAM memory of various flavors and so on, but it's mostly just those things. And FPGAs are kind of measured in terms of how many logic elements they've got. And the logic element is simplistically 1 lookup table and flip-flop combination. And the version 0.01 board of this project is going to have an FPGA that has approximately 4,000 logic elements. And it's got around 80 of those buffered pins, and the rest of the pins involve power rails, ground, JTAG for debugging, and maybe some miscellany. Except that the FPGA is just this big sea of gates. You know, it's just, I mean, it's just literally a matrix of these things that can be flexibly interconnected with certain constraints and so on. And so you have to program them. You have to basically provide a string of bits that magically goes into the FPGA and tells it connect this to this, this to that, this to the other thing. Set, you know, this pin to be an output and this other pin to be an input, and so on and so forth. And the initial 0.01 board will have some way of programming the target FPGA. The details are TBD. So, like, one idea is to arrange to put a Jetson Nano, which Nick described previously, I think, was it last month? Anyway, and basically take the chip off and wire it up to the target FPGA so that some of it can be programmed, possibly the whole thing programmed, tricking the system into programming the entire target FPGA via the USB interface of the Tang Nano board. But there are probably a lot cooler ideas, like say, well, I don't know. I'm not going to venture to guess, but there are folks that know a lot more about FPGAs than I do that probably can think of much easier ideas to do it. And then the board's going to have at least one footprint for a common ESP32 board, so that you can do things like use your language of choice, and it'll have some way to talk to the FPGA, and of course the ESP32 board provides USB, GPIO pins, ADD, maybe a DAC, I'm not sure, Wi-Fi, Bluetooth. It also has 2 cores that are very fast. It can run FreeRTOS. It's got a ridiculous amount of software available for it. What is this for? Well, the ESP32, you guys probably don't have any trouble imagining use cases for the ESP32. But what about the FPGA? FPGAs they shine for problems that require critical timing. Like, say, sensing a state change on a pin and doing some really clever stuff like, say, multiplies and math and other stuff, and being able to somehow respond on another pin very, very quickly. And so quickly, handle timing relationships. In fact, using purely combinatorial logic, the latency could be as little as maybe 10 or 20 nanoseconds for the chip that we've been looking at. And that kind of responsiveness for timing situations is simply not feasible with most MPUs. They either have to run at like 8 gigahertz, or they have to be, which is not imaginable. As you know, there aren't any 8 gigahertz MPUs that I know of. There are like mainframe, 80 arms in a package type chips, but they only run at 3, and so on. And then the second is problem space is one that requires very, very high speed, like slurping 32 bits out of a A to D converter and massaging it in a big hurry, and then outputting stuff that's meaningful. Like what? Like a 125 megahertz oscilloscope that's smart and drives, we intend for this initial board to have a ribbon cable interface to a nice little 800 by 640 color display, and this proposed oscilloscope could have some extremely advanced features. It could have features that would be only limited by imagination within certain bounds. This doesn't segue very well, but we talked about, okay, dropping back, a fundamental motivation for this project is for a lot of people to have fun. But what's fun? It's different for different people, and so this is what's fun for Nick and Pete. Nick's got this photo multiplier that is
very expensive.
Extraordinarily performant, I think, is how the marketing people would say, right? And he'd like to collect single photons and gather them up and detect cosmic rays, and also get signals from a giant scintillation crystal and Nick, why don't you explain what on earth that would be about?
Well, I have a 12-inch diameter scintillation crystal, which is worth more than I am. And that hooks into a 5-inch, and I have a brand new Hamamoto photomultiplier that goes on it. And this is this has intrigued me since I got it. And you can do things. I'm particularly interested in doing gamma ray spectroscopy, where you hit something with some high energy rays, look at the resulting bouncing photons, and by looking at the energy under the photons, you can determine what the material is. So it's basically a tricorder from Star Trek. They're around, and I have some scintillation crystals, but somebody sent me this. Somebody who will remain nameless sent me this gigantic scintillation crystal, and I want to do something with it. And so you have to be able to take very short pulses that come out of the photomultiplier on the order of 125, 150, maybe even more megahertz, and you accumulate those. You take the pulse coming in, you integrate it. You've got the total energy under the curve, and then you throw those in little bins, and then by looking at the bins, you can determine what the molecular structure of what you're targeting is. And do I have any practical purpose for that? Well, I could probably detect Sharon Harris if I ever went critical. It's just something I wanted to do, and the sort of the way that the name of the board, holy shit, is I wanted to create a board that if I saw it on Parks or one of the sites, I would say, I gotta have that. I gotta have that. Holy shit, that has everything I want. So the idea is to create a board that has all of the shit done for you. It's got a nice interface. It's got the crystal, and then there's an area on that where you can put whatever you want to. You can do a Eagle or a whatever CAD system layout and plunk it down into that space. And you know that the machinery, the low level stuff, it's sort of, I guess it's similar to the Raspberry Pi in that I want to make something that is incredibly useful to anyone. And I wanted something that you could give to high school students, and they could make LEDs blink. But it would be still something that isn't a toy. It was something that would excite me. So that was it may be slightly egotistical, but I want something that will say, I want that. I got to have one. And so that is the sort of the motivation, or at least my motivation. And the idea was to create a kind of a working group, get together, drink some beer or whatever, discuss how to do a board that the scope is one use case. Potentially you could do a software-defined radio with people who have RF expertise. You could do Fourier transforms, which FPGAs are pretty good for. You've got a whole bunch of things, but you've got a kind of a universal building block that will allow you to, that will give you the mechanics of interfacing to the FPGA. The software is all available for free. You've got a way in and out, which is more than the standard USB plug. You've got a Wi-Fi, you've got a Bluetooth, and so you've got a platform that is truly useful. And that's my aim. And the more people involved in this, the more fun it is.
Yeah. And that was very well put. Thank you, Nick. Many eons ago, I kept writing a little simple compiler, and the last version of it, and it was ended up on like a cartridge tape or 9-track tape or whatever, and it just got left behind. And I'm pulling this example out of my memory. This is not something that I would necessarily want to jump on tomorrow, but one use case that I could imagine is having an FPGA that's got many virtual machine implementations in it, and a compiler that's got a relatively simple backend that reorders the instructions, figures out dependencies and all this other mumbo jumbo that compilers have to do, and arranges for automatic parallelization, such as executing nested loops, operating across arrays, and crunching 50 elements or 50 sets of elements in one iteration, and so on and so forth, and then gathering up the partial results. And that would be my idea of fun, but there are other use cases, and really all of you have listened to this up to this point, and you might have some ideas that have just popped into your head. Would anybody like to share any ideas at this point?
Sure. I mean, anybody else can go before me, but I have one that I'm just itching at. Do you want me to describe it?
Go for it.
So at anybody, there's a book called On Intelligence that comes to mind immediately. Jeff Hawkins and Sandra Blakesley wrote it. They were studying sort of the intersection between everything we know about artificial intelligence and actual organic intelligence in mammalian brains. And in that book, they proposed what they claimed was a testable model of a set of relationships between very simple forms of neurons that intelligence would be an emergent artifact of having such a network set up. And having read that book and having looked at what you've got here in the exact description of logic elements with about 4 inputs and some form of state and a phase lock loop, and the ability to hold something in a flip-flop, that's about exactly what they said was required to prove or disprove this. At the time they wrote it, they said it would be way too expensive to build a machine that would do it. But this machine or a cluster of these machines would absolutely let someone put that together and see, is their model something from which some appearance of intelligence would emerge, or do you need the kinds of things we do today? Their claim was it doesn't require all the statistical modeling we do. It'd be really interesting to prove them right. It'd be really interesting to prove them wrong. And I just, as I hear you describe it, I'm like, oh, I want one of these, because that's exactly what you could do with it. Exactly what you could do with it. The only question is 4,000 enough? I think you might need a bunch of these, but it would work. So anyway.
But if you start out with 4,000, it's the idea is a plate.
Right. You build it with 4,000. You see how far you can get. If it turns out you only have the brain of a cockroach, then you can work your way up.
Yep. And I wouldn't mind making a cockroach.
There are much larger FPGAs than our target. I don't know how high the number goes, but it's tens of thousands at least.
Right. So the point is to start somewhere and prove the model, and then it's supposed to scale. You just repeat. You don't have to do anything new. You just repeat and increase the number. So if you can model it on this, then you have something to prove. Say, all right, now we just need a bigger one, or we need a cluster.
The problem is the big ones are really expensive, and that would be if you could actually get them in the first place. So you may be forced to just stick with this for now.
Potentially.
Yeah, exactly.
And if we can prove it, we can get a big one. If we're doing good stuff, then we can get a good one. We can get a big one. It's not,
Right. If we actually produce a cockroach that doesn't require someone to build the right statistical learning model, it's emergent of the architecture.
That's a good
Someone
point.
will give us a big one
Yeah.
right away.
Yeah, there's no question about being able to get a big one.
Any else? Any other ideas?
On that note, I'm going to just throw out, in case you didn't know, Hawkins has written a newer book since On Intelligence. I don't know if you've seen it or not, but he's written more on intelligence. So,
Yep.
Okay. Oh, right. Did I mention the fun aspect? Okay, so yeah, Nick and I were comparing notes about fun, and we overlapped on, I think, all of these, or all but one or something. And an obvious one is the kind of fun that you have sharing a project with camaraderie and so on. And if this goes as expected, it should fan out and involve lots of groups of people having fun and having camaraderie and so on. And then another one is teaching kids, and except that kids come in all ages, in my opinion. There are, well, anyway, and then
Yeah.
I probably misspelled this. The author, I wrote Kuja down phonetically from what Nick said, but for anybody that's familiar with the Dunning effect, it's something that some of us have to struggle with a lot, and it's a lot of fun to get feedback about whether you're full of BS or maybe on target on stuff. And anyway, that's a unusual but flavor of fun. And I find it pretty interesting that with an FPGA you can program anything that can be expressed in terms of digital logic. Anything. There just isn't anything that doesn't fit into an FPGA, except, as was previously mentioned, you might have to glue some of them together or get the really big ones, etc. Getting expensive, complicated stuff running, that's Nick gave you the two examples of that. And then it might require things like a nonprofit, or someone might want to take something coming out of this and make money with it or whatever, and we think that that would be a form of fun too. So we kind of anticipate discussions, but we would like to start a working group that meets physically at the Abbey Road Restaurant and Grill. It's at the intersection of Cary Parkway and Lake Pine, starting November 22nd. I've got it booked 6 to 9.
They have good hamburgers.
Good hamburgers, yep.
Good hamburgers, and for those that drink beer, I've been known to, upon occasion, drink beer. They have beer too, just to, let set your mind at ease.
I think that they will even allow me to bring in a cooler of non-alcoholic beer, because they don't have that, and someone at the bar told me why they don't sell non-alcoholic beer. In case anybody's curious, it's because they're banking on the effect on your forebrain to make you drink a lot of crappy industrial beer, and beer with no alcohol does not accomplish that. So it's against their business model. But anyway, the meeting will start at 7. So that basically allows time for folks to get something to eat without, trying to eat and talk or whatever. And an RSVP is preferred as a courtesy to the restaurant. And
are you using an indoor space or an outdoor space there?
Indoor.
So the indoor space seats 11 comfortably, with room for a couple more if they bring in a table. And there is an outdoor space that's covered with a rumor of heat sources. There weren't any when I visited, but there's some rumor of heat devices. And I'm thinking, well, okay, and I've got an unlimited supply of the N90 masks that came out of NC State, or that are coming out of NC State at a ridiculous rate. Very high, real deal masks, right? But, you know, electrostatic charges, properly designed, really good. They can be doubled up because they're not nearly as uncomfortable as an N95, but you could stick an N95 under it if you felt better about that. But my wife recommends that we get closer to the thing and figure out what we're going to do.
I think that makes a lot of sense. I mean, we don't know where things go from here. Hopefully they're going to get better and better, but Thanksgiving's coming.
Yeah.
What's the date you're meeting? It's the November 22nd?
Yep.
Yeah, it's on the slide. It's the second bullet of the slide.
I see it.
Oh, okay. I wondered if I had pushed a button that had vanished it.
What day is that?
Monday.
That is a Monday. It's designed to be right in between these meetings, these virtual TriEmbed meetings.
What is the RSVP mechanism for this? Are you using Meetup or something, or is it email?
That's
you
a good
or what?
question. I don't have another slide. Nick, what do you suggest?
Send us an email.
Yeah, send us an email. Okay, so my email address is PETE, like Pete. Oh, here. So do you see where it says Pete Soper Apex Proto Factory? My email is Pete@Apex Proto Factory, all run together with no spaces. And unless I'm mistaken, email addresses are case insensitive.
Hey,
Does
Pete,
that
you
make
can
sense?
also post it on the. Pete, are you in a position where you can type much tonight? Because what I could do is I could post that on the chat channel.
Can I type that into the chat channel? I think I can. Let me figure out how to do that. Just a sec.
I can do it for you, Pete. If you're on like a phone or something where you don't have as much typing convenience.
You'd have to. Well, actually, let me turn my screen sharing back off.
It's already there.
Oh, it is? Oh, but my screen sharing's still on.
Yeah, but Phil just posted it up for you.
Okay, all right, good. I don't know if you can see my right arm, but I'm having to run this mouse from the most unimaginably uncomfortable position. So I appreciate you guys, because and every time I take my hand off of it, the mouse focus jumps, and so I lose focus out of the window. So thank you for the chat.
I made the simplifying assumption that your TLD is .com. If that's wrong, let me know and I'll fix it.
No, that's correct. That's it. Okay.
And as to the cockroach, I'm thinking if you could even get one leg of a cockroach to begin to wiggle using a setup like this, then you just need another 6 or 8 legs. You know, that would be
100%. If you can get amoeba-like behavior, you're winning.
Yeah, and that would be a sort of the ideal demonstration of such a thing, because you've essentially got independent logics. I have a soft spot for octopuses, which would essentially have a brain in each of the tentacles.
I love it.
So
great. So we're going to get the Matrix, but the machines will act like they're inspired by cockroaches and octopuses.
Yeah.
Oh.
It's going to be good.
Oh boy, I'm going to start buying laser pistols tomorrow. Stocking.
Well, that might help. Suggest a name for this thing, which might be the first order of business at the face-to-face, or something like that. I don't know.
Sometimes names take time to emerge properly. It's good when you brainstorm, but sometimes you don't want to name it prematurely.
Exactly, and right. So don't read anything. Don't read too much into that asterisk board, whatever the other name was. That was just
us. That was the emotion when we sort of were hammering out some of what we were doing. What my focus was is I got to have one of these. I want to make something that I got to have. That if I saw it on OS Parks or wherever I saw it, eBay, I want one of those. And if it has the FPGA, if it has an ESP32 in an area where I can drop in my own Eagle or whatever your favorite CAD package, I can drop my own stuff in there. I would walk over hot coals to get one of those. And that's the measure of what I consider to be a good design.
In the case of this asterisk board, that's a old Unix, Linux wildcard, right? Anything board, right? So that's where that came from. Anyway, time is passing fast. So any other questions, or shall we move on? Okay.
All right. Thanks, Pete. All right. Let me see if I can share my screen. All right. Can everyone see that and hear me?
Yep, you're coming over pretty good.
Great. So I'm going to talk about a sand bony. 4 years ago, at a meeting of this group, the problem of the month was how could you accurately measure the height of the sand floor in this horse arena? And there were, lively discussion about different ways. And I have spent 4 years continuing to think about it and wanting to do something. The goal here is to end up with a relatively level surface in this arena. And so I've come up with a design for something that I'm calling the sand bony. It's like a Zamboni for sand rather than for ice. And so it's going to be a trailer that gets towed behind some other vehicle. To begin with, it'll be driven by me. Ultimately, probably it will be autonomous. Drag a 3-foot wide blade or so. It has a linear actuator that moves the wheels up and down, which in effect moves the blade down and up. And then the idea for how to tell your altitude is a plane of laser light that's projected out across the floor of the arena. And my favorite modeling tool is OpenSCAD. And so I designed my little trailer here that gets towed behind a golf cart or a lawn tractor. It has the 3-foot blade here in the middle, and then it has some wheels at the back with a linear actuator that can move the wheels up and down. So one of the first things I had to work on was how am I going to do this laser light plane? So we have a building that has big, massive steel beams running across, and we can attach things to the edges of the building. So my plan is I bought some cheap laser pointers from Amazon, and I need them to rotate, so I 3D printed a little adapter to hold the laser pointer on the end of a RC servo. And so I can sweep back and forth, maybe up to 180 degrees, depends on what kind of servo I get. But getting a nice level plane is a little bit of an issue, so we need some good ways to level things. So here is a mount I built that has a couple of pieces of steel I-beam, steel angle iron welded together. And then you can see some springs holding these two layers together with some bolts. The bolts are threaded, so you can move them up and down. You can move all of them up and down to move the plane up and down, and then you can adjust the bolts at the ends here to get your level correct. And then on the corner of that angle iron, here's a picture of the servo with the laser pointer on it. And then this is a 3D cell battery pack and a small ESP8266 processor that talks to the servo and causes it to waggle back and forth.
I'm surprised you didn't think, those standard room leveling lasers that you can get over at Home Depot and the other home centers.
Yep.
I'm surprised you didn't start with something like that. I know that the laser light's not strong enough to stretch across the large of a space that you're looking at, but I would be curious to tear one of those apart and see how they're doing it.
So I have a laser level built by Craftsman, rotary laser. I don't really want to have to go out and put the laser in the middle of the arena and level it. And so I wanted something that I could mount on the perimeter somewhere.
I have a laser level. I also have some galvos mirrors for lasers. I've got a kind of high-powered laser in them, which probably wouldn't be good, scare people. But rather than project lines, if you project circles of changing radius, you can pick up a lot of the geometry that is far more difficult to work out with a simple line. The understanding conical geometry is fairly easy, and you can pick up minor bumps. A lot of things show up very, very nicely, and the math ends up being rather nice if you can do. You might even be able to get away with projecting an image out of the front of whatever you're driving around on. I've done work on 3D scanners that use conical projections, and you say the math ends up being nice, and you tend to get X, Y positions, which you don't get with a simple line.
The mechanics are easier too because they're using rotary motors as opposed to servos, so that it's just continuously rotating.
Yeah, I don't want the laser on the robot on the movable portion.
Even if it's not on the movable portion, I say if you vary that, you might be able to do something which was centrifugally driven, so you can have varying sizes of circles, and you can pick up the line will just give you sort of the one-dimensional. A circle will give you even a scanning circle will give you the two-dimensional information to be able to pick up variations in height and bumps, which would be difficult with a single line.
Yeah. Okay. Well, let me continue. I appreciate the comments. I think that solves a different problem than the problem I'm trying to solve.
I'm good at that.
Me too.
So I'm playing the video here. I don't know if
It's coming
everyone
through.
is seeing that or not. So that's
Yep,
waggling
it's coming through.
back and forth only about 10 degrees. The idea is that one of the things I've noticed about my laser level is that if I'm having it spin 360 degrees with it, which is its normal mode of operation, it takes a while for the laser to get around. It's moving pretty fast, and it covering a lot of space, and the beam is pretty weak by the time you go out 100 feet, and it's sweeping past you really, really fast. By waggling back and forth, as long as the robot is in that 10-degree arc, I seem to get a pretty good beam. And so I will have to have some communication somehow to know which 10-degree arc this thing should be running in depending on where the robot is. But I have some ideas how to solve that. So then I need something on the robot to detect this beam of light from the laser. And so I tried out some phototransistors, some photoresistors, some opto sensor things, and I ended up going with phototransistors from Adafruit. I heard a beep. Was that?
That was probably my email. I apologize.
No problem. I just want to make sure it wasn't somebody trying to communicate to me. So I laid out this small board, uses an MCP 3008, which is an 8-channel analog to digital converter. And then I've got my 8 phototransistors, which look like little LEDs, and a companion resistor that makes a photo divider, and the SPI interface. And I was talking to a buddy, and we were thinking, well, how many of these transistors am I going to need, and what directions are they going to have to point in, and am I going to need dozens of them? And he talked about using acrylic plexiglass as light pipes to try to collect this light. And so that sounded like a great idea to me, and I tried it out, and it works really well. I'm very impressed with it. So this is some laser cut 1/4-inch plexiglass. I don't know that this is the optimal shape, but it seems to work pretty good. I may play around with that a little bit. The circuit board is in the middle. It looks like this bolt here goes through the middle, but it doesn't. It's off to the edge a bit. And so the laser sweeps past here, and it bounces around inside of whatever layer it hits. Between them, I've got a little piece of cardboard to try to minimize the light that leaks from layer to layer. And then, so here's another little video. This was an earlier test. And so this is a view about 45 degrees off of the direction, or 135 degrees off the direction that the laser is shining. And, it hits, there's a little spot somewhere on this layer over here, and the whole thing just lights up. And so I was really, really happy with the result there. And I can demonstrate with the new one the larger one. I can show you a demo in a few minutes here. So then once we've detected what layer we're on, the goal will be to try to keep that laser. This detector will be mounted on the trailer, rigidly attached to the blade. And so as you move the blade up and down, the detector will move up and down across this plane of laser light. And the goal will be to adjust the linear actuator so that the laser light stays on, say, the fourth layer of the detector. And so if it's too high, we'll move it down. If it's too low, we'll move it up. And so I needed a motor driver to run the linear actuator. And so I chose one from Pololu. It has some driver pins. It's not I2C or SPI or anything. It just has direct GPIO pins. So it has some big pads to get voltage in and voltage out to the motor, and then some control things for PWMing if you want to change the speed of the motor. There's a direction bit that says whether we're running forwards or backwards. There's a sleep input, a fault output, and then there's also a current output, which senses how much current the motor is driving. So I plan to use that to run the linear actuator either forward or backward. There's only 2 wires that go to the DC motor that's in the linear actuator. And then for software, and these processes might run on different ESP8266s or possibly on a Raspberry Pi, or I also have some Jetson Nano boards that I might use. So we need to pull the analog to digital chip to see which, if any, of the 8 channels are extra bright. You can cut out the current ambient contribution by finding the minimum layer and subtracting that value from all the others. And so it should be pretty tolerant of changes in the ambient light. I've been using MQTT a lot. That allows me to have separate chips that communicate with one another. And so, one thing just pulls the detector and tells what layer got illuminated and sends that off to MQTT. Anybody that wants to monitor that can subscribe to that topic from the MQTT broker. Now, this stack of 8 1/4-inch things is only about 2 inches high. If we go down in a hole that's 3 inches deep, the beam might go off the top or might go off the bottom. I'm thinking that, if somebody is monitoring the layers, it can tell whether it went off the top or off the bottom and give a suggestion on which way to move the blade. Or if it goes off the side, that is a little bit more difficult to detect, but I have some ideas. There's some timing of that waggle back and forth. If you're off to one end, the timing between when it sweeps to the right versus when it sweeps to the left is one way, and if you're off to the other side, it's the other way. So I think I can probably detect that as well.
Paul, what happens if one wheel is in a hole and the other wheel is not? Can you do any angling?
So it does record proportional values, so you can end up with 2 layers that have some contribution. So I would imagine that if it's tilted at an angle, you will, it'll cross the detector diagonally. I don't expect real strong tilt. But that's possible.
So, are you adjusting height on with a single actuator, or can you independently adjust left and right wheels?
The current design just has one actuator. I could imagine a design that had two. I don't think I would need that.
You don't think you need a tilt of anything?
I don't think so. The way they normally maintain the arena is they run an ATV with a drag on the back. Some people use like box springs.
Yeah.
A bunch of wire that gets pulled behind it, and that smooths out the hoof prints and the little bumps. And when they poop in a little pile, it spreads that out into smaller and smaller pieces. What I'm trying to get is the hills and valleys that are 10 or 20 feet apart, that go by, maybe 3 or 4, 5-inch difference at the most.
Yeah, one of the things that I saw in one place I visited, when they were doing rodeos and stuff, when they go to smooth it with just the ATV and the I don't know if you call it a spreader or whatever the thing was in the back, as they kept going over it in between runs, the hills and valleys got more defined, kind of like sand dunes almost, because it would drag more up it and drag more down. It was kind of weird, but the hills and valleys got more and more defined every time they kept running over it.
Yeah, you can see a washboard effect. So they have a tractor
exactly
at this arena, and with a box blade attached to the back of a tractor. What happens is as you rise up onto a high spot, the blade, the tractor tilts and the blade digs in behind the tractor, right? And that's actually digging into the low spot leading up to the hill that you're climbing. And then as you get to the top of the high spot and go down the other side of the hill, the blade lifts up and doesn't scrape. And so you get washboard like you do on dirt roads. The period.
That's exactly what was happening.
Yeah. The period of the washboard depends on the distance between the axles and the blade. And I've actually seen it on this little one. It's only about a foot apart. The washboard effect.
So is the active control meant to undo the washboard effect?
Yes, and I think that having it as a trailer helps, as opposed to being rigidly attached to the frame of the vehicle that's climbing up and down.
Oh, that makes sense.
Yeah, I'd almost think though, what I used to experience pulling a garden trailer behind my quad is as the quad would go up and down little hills and valleys, the trailer would hit, where the hinge is, where it's connected.
Yep.
It would bend up and down, so the little garden cart would flip up and down a little bit.
Yep, that happens. Yep.
So what I found was a 4-wheeled cart worked a lot better than a 2-wheeled cart.
Okay.
Where the pin thing that you're pulling, where it has hinges on both ends of it, right, so it can move up and down both sides independently.
Yeah. So road graders have the blade in between the wheels, and they're much less susceptible to this washboarding effect. And so if you had, like you're saying, 4 wheels with the blade in the middle, that might be pretty good. My hope is that, or maybe it's my fear, I may have to run quite slowly because the linear actuator I have is not all that fast. And for it to move an inch takes 10, 15 seconds or something. And so it may require me to drive really, really slowly and, have it constantly adjusting the height up and down. If you can respond fast enough, you can eliminate the washboard.
Can you use leverage to gain speed and lose power?
Probably.
What about a more mechanical oriented dampener type of thingy, where you're using springs to help gain the speed for correction?
Yeah, I don't know how much. I want to test what I have first and see if washboarding is an issue, and see how fast I can drive before I outrun the linear actuator. My hope is that by running this frequently, the absolute difference across the arena will get smaller and smaller, and this will just be a maintenance thing that I'm trying to grade out the last 1 inch across 100 feet as opposed to the 10 inches that are currently present.
So it sounds like you've got a prototype that's actually working.
I have a trailer that works. I can raise and lower it with a switch manually. And I have a lot of the pieces for some automation, but I haven't actually started full testing.
And what are you using to power it? Are you powering it off of the tractor with 12 volts?
I have a 12-volt car battery that I lug along with me.
Actually, the battery can almost act as a weight, like a stabilizer in the trailer.
Yep. And then I also bought a 9-axis inertial monitoring unit. I would like to think that the IMU could feed a neural network that would tell me where I was height-wise, so that I wouldn't need the laser level. But I know for all these neural networks, you need some ground truth to train the networks, and so I'm planning on putting one of these on the trailer and logging a bunch of data along with the data from the detector, and perhaps training a neural net to eliminate the detector. And then I've also thought about using a camera instead of this fancy detector. If I just had a white PVC pipe sticking up, the camera could see the red line drawing across the pipe and know whether it's higher or lower than it ought to be.
Paul, this is John W. That's my concern, is sort of the this visible red laser shining across 100 feet in the sunlight at phototransistors. Have you looked at like modulating, like doing this narrow band, like modulating them like an IR remote control, and maybe using IR, and then recovering this signal strength as an AM demodulated
phase synchronous demodulation.
Yes, because it's
I have not looked at that. I've thought about that, and I hope that I don't have to do that.
So transistors have a pretty limited dynamic range. They just tend to saturate when they get some light. They have their own gain.
Right.
So typically, there's a thing in the industry called light curtains. Have you ever heard of these things?
No.
So they basically have an array of LEDs or lasers on one side with some optics. So they have kind of a narrow beam pattern, and then they have another, and it's in like a bar, like a 3-foot long bar. There's a company, STI makes them, and Banner Engineering makes them. And you might it's sort of like an electronic fence that you might put around a machine tool that's real dangerous in a factory. And if anybody walks through this light curtain, it trips it, but there's no, there's nothing in between. But they also use these things in like UPS and people like that, packaging places use them to measure the size of boxes going down a conveyor,
Okay.
So they got about I don't know, something like your resolution, but they're usually longer. They have maybe 36, emitter detector pairs that they scan that are kind of in pairs, and they get this little, because they're synchronized, they can narrow the bandwidth, and they don't have to have this photodiode be wide open all the time. They can sort of they can scan them, and they measure the size of boxes with they measure luggage, like Denver Airport has a fancy luggage handling system that didn't work very well, but it's full of these light curtains too. It might be it's sort of what you've built, except that it's modulated and it's scanned, and it's, if you get into these problems of saturation, which I think these things generally use photodiodes with current to voltage converter amplifiers, just kind of op amp, not a big deal, but you get a lot more dynamic range, probably, like 6 decades of dynamic range instead of maybe 3 out of a phototransistor.
Okay.
So might be worth looking at. Infrared too. I think there's a lot of, if you're in a place that has, sunlight glinting in and all that kind of stuff, I can imagine, your sensor array just saturating.
Yep.
So,
yeah.
The other thing I was thinking
I don't think
of-
going to infrared is going to solve that.
Yeah, I was thinking of something too that the Navy uses. They call the ball for when the pilots are on angle, approach angle, coming into the aircraft carrier.
Yep.
Where at a slightly different degree angle, it changes colors.
Yep, like VASI and PAPI landing indicators at airports.
Yeah. Optical, it's like an optical gadget. Yeah, that's a good idea. I think. Yeah, I don't know that the infrared. I think the infrared might help. I mean, that's what garage door. Garage doors use infrared for that reason. So, because there's not a lot of infrared in sunlight. I mean, not a ton.
It's you would. It would be a lot. I may have some interference filters that if I don't, then you can get an interference filter which will only see the red coming out of a semiconductor laser.
Yeah, that's probably, it's something like that. Just limit your bandwidth.
Yeah.
In the analog domain and in the light domain, it seems like.
Okay.
Yeah.
Yeah, one of the next things I was going to try was doing some testing of the detector in the arena and see at what distance I can, tuning that resistor in the voltage divider is a trade-off between sensitivity and
you can
or
use a fairly cheap op amp and a photodiode and probably get a lot better results if you find you've got kind of a limited dynamic range.
Yeah.
I have some ancient OPT 101s, which is an old Burrow Brown transconductional amplifier with a fairly large photodiode attached.
I bought 8 Opto 101s, Opt 101s. I have not tested them. They're in 8-pin dip packages.
Yep.
And
yeah, that's the part.
Yep.
You might want to look at these light curtains by STI or Banner. I mean, it's interesting. It's a similar problem.
Yep.
But the OPT 101s I've used in a number of things, and they're one of my go-to parts.
Okay. Yeah, the light active area is only about half of the width, so we might have to do a little bit of lensing between layers or something.
I have a bunch of gel filters, and I can attach a gel filter to the surface very nicely with optical adhesive, and get them to tailor to whatever frequency I want to look at.
Right, but you can line the spot up to hit the active area.
Mm-hmm.
I can't do that, right? Mine bounces around. And
Yeah, you
so-
almost have to have an array of receptors,
right,
and that way, if it's too high or too low, it's still hitting the receptor, but you know which one.
the physical layout of the OPT 101s doesn't gives you only about 50% coverage.
Mm-hmm.
I like your stacked acrylic gadget. That's clever. I mean, I think that's nice, and I'm amazed how much it lights up with that little laser on it.
Yeah, I was too.
Yeah, that's one of the reasons I asked about the two wheels, because if you had one at each side, you could also use the timing between the two to get some more information about positions.
The tilt, yeah. And so I mentioned the Jetson Nano. You know, I used to work at NVIDIA. This is their version of a Raspberry Pi with a GPU on it that can do neural network and stuff. And every time I try to use one of these things, it doesn't go well. You know, and I do some Google searches and I find 100,000 hits, 999,000 of them are, or 99,000 of them are Raspberry Pi related. If you limit it to the Jetson forums, you can get a little bit of better results. But you know, so I just tried to do hardware SPI, talking to my A to D chip, and it didn't work. You know, I found a nice article on how to hook up SPI to Jetson Nano. Well, to Jetson.
Didn't Adafruit just have something like that where they just talked about using the Jetson Nano and the GPU for doing some fast calculations? It was in one of their afternoon tech blogs.
Yeah, I mean, there's a website called Jetson Hacks, and it's just
they're using CircuitPython to program it.
Yeah, I downloaded CircuitPython, and you know, there are undocumented things you have to do to get it to work. And I don't know how the people that wrote the blog articles got it to work without doing the things that you have to do that aren't published, but they didn't say what they were. And so there's more digging to do, and I don't really enjoy doing that. You know, I can do a lot of stuff with Linux. I don't enjoy doing it. I don't enjoy programming SD cards. And so I'm retired and can do fun things. So there are a lot more things I'd rather do than mess with a Jetson Nano. But I probably will do a little bit more to try to figure out what's going on. So I think that's the last slide. So I'm going to rotate my laptop.
It's alive.
It's alive. And so there is the servo with the little laser pointer on it. And here is the detector. I'll turn it upside down so I can get it in the beam. But boy, you know, it lights up the level pretty accurately. You ought to be able to detect that. If you tilt it a little bit, it'll light up a couple of them. It doesn't really matter what the orientation is.
What's the dispersion of the beam going to be at, you know, these kind of ranges, like 50 feet?
Right. I can make it sweep a smaller sector.
But how tall is the beam going to be at 50 feet?
Oh, the laser stays pretty well collimated. I expect it to be half an inch, maybe at 75 feet. My goal starting out was to be plus or minus an inch. I'd like to get better than that, plus or minus half an inch. I'm open to putting these laser things at multiple points around the arena. One of my concerns is that the tow vehicle and or operator on it will obscure some line of sight from some portions of the arena. And so if that's where the laser is, we're going to need another laser.
So your intent is to have them at least at all four corners, or?
Yeah, 3, or the other thing. So there's kind of a global planning that has to be done here. You don't want to go out there and find a high spot and start plowing up the dirt and pull it onto an even higher spot, right? You'd like to find the high spots and pull them toward the low spots. And without knowing where they are, that's kind of tough. But humans are pretty good at looking around and saying, oh, there's the high spot, there's the low spot. I'll go from that way to that way. I can imagine a fleet of little RC trucks with these detectors on them that go drive around the arena for a while, recording where they are and what the altitude is, and then somebody doing some path planning and say, oh, well, I know I want to move it from dirt from here toward there. I'm going to run my plow in this direction.
Well, that's
I had a thought of taking your laser and having it on a belt drive to move it up and down, and you move it down and down and down until it starts hitting the peaks of the dirt. And then as you level those out, you move it down just another fraction and hit more peaks of dirt.
Yeah, I mean, that's like radar, though, then, right? You only get to see the first peak.
True.
But that's, a possibility. I kind of like having it a foot up off or 2 feet off the ground. I'd rather not have it at operator eye level who's driving the tow vehicle.
No, I was just talking about your initial finding high spots, low spots. Then it would raise up to your detection level for operation.
Yep. And I've thought about getting a LiDAR and doing SLAM, and maybe I'll do that in the future, but that involves a whole lot more Linux programming, which I'm not really happy about doing at the moment. Have it run ROS and all kinds of cool things you could do.
Is there kind of a market for this thing, Paul? I mean, are there, if you could crack this, are there people that want this?
I mean, most of these places are farms, and they already have a box blade, and they're willing to go out a couple times a year and spend a few hours and get it a little bit better. The more often you run, the more often you spend some time to keep it flat, the flatter it stays. The people out at the fairgrounds, that horse arena, they run a tractor after almost every class. And so it stays pretty flat. And they have people out there with rakes filling in the divots where the horses come down out of the jumps and make big holes and things.
So all you have to do is make it autonomous, and it can be run every night unattended.
That's right. Yeah, I mean,
That's the Zamboni part, right?
that's the Roomba Zamboni.
Yeah.
For arenas, Sandboni. Yep.
There's a related thing that I've seen where they're in California. They build all these houses on slabs, and if they build on expansive soils, and they don't tamp everything down just right and get all the soil cut and filled correctly, it'll crack the slab in half.
Right.
So they do this thing where they go through the house and they measure the level of the floor in 100 points. They just sort of go around, and they use a water manometer. So they put a manometer at the front door. They put the reference manometer at the front door, and they zero it. And then they got this tubing. It's full of water, usually colored water.
Yep.
And they walk around the house all over. Hopefully this colored water tube doesn't break while they're doing it. And they've got this sharp spike that goes through the carpet and touches the slab.
Okay.
They get this sort of, a map of the topography of the slab. But they're dragging this tube around all the time. That's actually a pretty big. This thing would be better than that. I mean, it's a related problem, but they want to measure stuff to about 1/10 of an inch. It's a little more accurate.
Yeah. Yeah, I was planning on doing exactly that for setting for leveling the lasers in the arena. Right? I get a garden hose with some smaller diameter tubes at each end. And like you say, kind of a big U with colored water, at least at the ends.
Yeah.
And use that to make sure the light on one side is shining at a target that I would put at the other side at the same level.
Yeah, I think they use bigger tubing than I would expect because.
Yeah, I've used a garden hose before.
Yeah, that's about the size that they use because if you try to use something small and keep it real small, the water won't flow. It's got a lot of stick, it's got a lot of friction.
Yep.
But, California has the advantage. It's built on one massive shake table, which is self-leveling.
That's true. That's true. Yeah. You can shake all the bubbles out of the water.
Yeah, the whole thing. I mean, you could put your entire riding ring on a shake table, and it's
add a little water, and you got liquefaction.
Yeah,
that would settle it out pretty flat.
And I spent 2 years working for a civil engineer who did exactly this kind of thing, checking on building floors and taking measurements around the room and then drawing them up in CAD. And we used an industrial self-leveling spinning laser that sat in the middle of the room that we were measuring, and we took every 2 or 3, depending on how bad it was, from 2 or 3 measurements in a room to every 2 or 3 feet in a room to identify where the high and low spots were.
Yep.
Yeah, my wife's a geologist, and she worked. There were all these people suing each other. The builders were suing the grading company, and the grading company was suing the geologist, and the geologist was suing the builder, and a lot of finger pointing. But this thing worked well because you could go into a furnished house, and go into rooms and go around corners and things like that. It was really, I was amazed how simple it was. But yeah, my wife, there's a lot of this going on around Southern California still probably.
Okay, I'm going to stop the recording.